Hello everyone. Today we are going to discuss about a high yielding topic in biostatistics, that is normal distribution. And I am Dr. Anusha, Assistant Professor in the Department of Community Medicine.
So this normal distribution is also known as normal curve or Gaussian distribution or Gaussian curve. So any terminology can be given in the question. And this normal distribution curve will be drawn for continuous variables. Continuous variables means quantitative variables that do have continuous nature. Say for example hemoglobin, blood glucose, lipids, serum lipids, and age. So they are continuous variables. So this normal distribution curve we can draw for only continuous variables. And that too, so it is prepared for large number of observations taken at a representative sample. And from those large number of observations, we have drawn frequency distribution table. And from that frequency distribution table, we have drawn a curve with normal narrow class intervals, that means 2 3 4 like that narrow class intervals. We have drawn a curve. So in that scenarios we will get a smooth symmetrical curve. So that is normal distribution curve. Say for example hemoglobin levels in a class of having 250 members, 250 MBBS students, blood sample is taken and serum hemoglobin level is checked, and those hemoglobin levels are drawn on x-axis. Hemoglobin levels will be there, and in y-axis how many students are having that much hemoglobin. Say for example hemoglobin level between 7 to 8 will be there for some people, 8 to 9, 9 to 10, or if it is 8.6, 9.6, 10.6 like that, it will be there. So we will represent it with dots, and we will attach each dot and we will get a curve. So that is normal curve. If the observations are following normal distribution, then only we will call it as a normal distribution or normal curve. If they are not following normal distribution, we will call it as skewed distribution. And now we will see what are the characteristics of normal distribution curve. As you can see, it is a bell-shaped curve. Like in the bell which will be there in the temple, it is also a bell-shaped curve. And this curve is bilaterally symmetrical. That means left and right sides both are mirror images of each other. And point of coincidence, which is the line drawn from the apex of the convexity, so the line drawn in the middle, so that point is mean is equal to median is equal to mode. So that is nothing but in the normal distribution curve, mean, median, mode will coincide. It will be in the center. And total area under the curve is 1 or 100%. And as you can see in the curve, there is convexity or apex in the middle, and point of inflection is where the convexity of the normal distribution curve changes to concavity. So as you can see, apex is at the center and at the peak, and this convexity is gradually, while coming down, it is shifting into concavity. So this point of inflection is a point where this convexity is being converted into concavity. And exact location of this point of inflection on the x-axis is at one standard deviation. So one standard deviation means two sides. So if it is left side, it is minus one standard deviation, and if it is at right side, plus one standard deviation. So that is nothing but at one standard deviation on x-axis, this normal distribution curve, convexity is turning into concavity. So this normal distribution curve is having two inflections. One is at the right side, one is at the left side. And we are seeing central convexity. And both extremes are concave. And tail never touches the baseline. As this normal distribution curve, we have infinite values. So this right side also will extend till infinity, and left side also will extend till infinity. So this tail will never touch the baseline. So these are the characteristics of normal distribution curve. So here in this image you can see the normal distribution curve in detail. So the point which is extending from the peak of the normal distribution curve to the x-axis is mean is equal to median is equal to mode. And right side is plus 1 standard deviation, left side is minus 1 standard deviation, and likewise minus 2 standard deviation, plus 2 standard deviation, and minus 3 standard deviation, and plus 3 standard deviation. So now we will see how much area it is covering. Say for example, we have taken age of say for example 100 people. So this data, if it is following normal distribution, then 68% of the observations will be there within one standard deviation. So that is nothing but from minus 1 standard deviation to mean, and from mean to plus 1 standard deviation. So 68.2% of the values will lie within one standard deviation, and 95% of the values will lie within 2 standard deviations. So that is nothing but from minus 2 standard deviation to plus 2 standard deviation, 95.4% of the observations will be there. That means 95% of the people's age will be within this minus 2 standard deviation to plus 2 standard deviation. And likewise 99.7% of the values will lie between minus 3 standard deviation to plus 3 standard deviation. So in the same example, the ages of 99.7% of the people sample's age will lie between minus 3 standard deviation to plus 3 standard deviation. And how much is remaining? Only 0.3 is remaining. So that 0.3% of the values will lie, some will be on to the left side and some will be on to the right side. So 0.3% is very less. So that's why data falling outside 3 standard deviation will signify rare occurrences. Rare occurrence means it is as we discussed, it is less than 0.3%. So in the taken population, only 0.3% 0.3% values will be either right side of the more than 3 standard deviation or left side of the minus 3 standard deviation. And in this image, till 1 standard deviation, it is denoted in the green color, and so from 1 standard deviation to 2 standard deviation, it is given as yellow color, and from 2 standard deviation to 3 standard deviation, it is given in red color. So as we know that left and right, both sides are mirror images of each other, they are sharing exactly half. In that 68.2%, 34.1% is on left side, which is minus 1 standard deviation to mean, and remaining 34.1% will be on the right side as mean to plus 1 standard deviation, because these two are mirror images and exactly sharing half percentages. But is normal distribution will be possible every time? No. So sometimes the variables or the observations will not follow normal distribution. So that is known as skewed distribution. So here we will take one example. Say for example, MBBS third year community medicine pre-final exam has been conducted. So in that the marks are like following. So majority of the students got good marks like 80, 70 and above for 100 marks. So then the majority of the students marks will be on the right side. So if the majority of the students marks are on right side means, so the convexity will be on the right side. So that is negative skew distribution. And say for example sudden slip test was conducted in the same community medicine exam, so most of the students did not prepare well, and in this scenario for 100 marks majority of the students got below 40 marks for 100 marks. So then in that scenario, so majority of the students marks will be at left side, so that is positive skewed distribution. So skewed distribution means the observations are not following normal distribution. Normal distribution means say for example we have conducted test for 100 marks, exactly in 100 students batch 50 students got 0 to 50 marks and 50 students got 50 to 100 marks. So that is normal distribution. But in reality, this normal distribution is not possible every time. The distribution which is not following normal distribution is skewed distribution. So it is a measure of asymmetry of the probability distribution of a real value random variable about its mean. So negative skewed is also known as left skewed distribution. So to tell whether it is left skewed or right skewed, you should see the tail. So the longest tail is at left side. So it is in the first image. The longest tail is at the left side. So it is left skewed distribution. In the right image, the longest tail is at right side. So this is right skewed distribution or positive skewed distribution. Left skewed distribution is also known as negative skewed distribution. And in the first example, negative skewed distribution or left skewed distribution, so majority of the observations are on the right side. So at the higher end. So higher end means high. So here most repeating observation is mode. So mode will be high compared to median compared to mean. So mean will be shifted to somewhat left side because of extreme values in the left side. So extreme values means extremely low values. Say for example, few students got 5 marks, 10 marks like that. So because of that, this mean is shifting from 70 marks, 60 marks to 50 marks. So it is shifting to left side to the lower. And in the second example, so most of the observations are at the lower side. Say for example, lower marks. So most of the observations means mode. Here mode will be lowest compared to median compared to mean. So mean will be high means this mean will be shifted from the exact peak to right side higher end because of higher extremity. Say for example, some students got 80 marks like that. So this mean will be shifted to right side or higher side. So this is about skewed distribution. So you should remember that if it is not following normal distribution, we will call it as skewed distribution. So this is nothing but asymmetry. To understand in detail about the calculation, we will see with one example. So here, let us assume the body weight in a large population follows normal distribution. So that means they are only telling that this body weight is following normal distribution, and the mean body weight of that population is 65 kgs and standard deviation is 5 kgs. So here we can calculate within one standard deviation how many people will be there, within two standard deviation how many people will be there, and within three standard deviation how many people will be there. We can see. So mean plus or minus one standard deviation. So is equal to mean is 65 kgs plus one standard deviation means 1 into 5. So that is 5. So 65 plus 5 and minus 5. So it is nothing but 60 kgs to 70 kgs. That means within one standard deviation, 60 to 70 kgs people are coming. So one standard deviation means how much area? 68% of the population. So in the given larger population, 68% of the population's body weight will be from 60 kgs to 70 kgs. So like that we can tell. And next we will calculate for two standard deviation. So mean plus or minus two standard deviation. So that is 65 kgs plus 2 into 5 is 10. So 65 plus 10 minus 10. So that is 55 to 75 kgs. So what does it mean? About 95% of the population's body weight is within the range of 55 to 75 kgs. And in the same way we can calculate for the 3 standard deviation also. So mean plus or minus 3 standard deviation is equal to 65 plus 3 into 5. So this is 15. So 65 plus 15 and minus 15. So that is nothing but 50 to 80 kgs body weight. So what does it mean? 99.7% of the population, in that large population, 99.7% of the population's body weight is within the range of 50 to 80 kgs, and only less than 0.3% population's weight will be either less than 50 or more than 80. So which is very rare. So like this we should interpret with an example. So this is also same, mean plus or minus one standard deviation means in the same example 60 to 70 kgs covers 68.3% of the normal curve. So that is within one standard deviation. And mean plus or minus 2 standard deviation, that means 55 kgs to 75 kgs, covers 95.4% of the normal curve. So you can see the area under the curve. How much? Majority. So 95% means majority only. And mean plus or minus 3 standard deviation means from 50 kgs left side to right side till 50 to 80 kgs covers 99% of the normal curve. So like this we should interpret if any example is given, like if the observations are following normal distribution, they will give mean and they will give standard deviation, and with help of that within one standard deviation how much is there, within two standard deviation, so what will be the observations, like that we should be able to calculate. So here in this example they asked us to calculate the body weight. So within what range the body weight will be there for one standard deviation, two standard deviation and three standard deviation. So I have shown you how to calculate with one example, and here I have given one question and exercise so that you will calculate. So the question is, in a community health survey, fasting blood glucose levels of 500 adult males were measured. So the data showed normal distribution. So underline it is normal distribution with mean of 100 milligrams per deciliter and standard deviation of 10 milligrams per deciliter. Approximately what percentage of population is expected to have fasting blood glucose level between 80 mg per deciliter and 120 mg per deciliter? So like in the previous example, we should calculate. So they have given mean, they have given standard deviation. So whether this 80 milligrams per deciliter and 120 milligrams per deciliter is within one standard deviation or two standard deviation or three standard deviation, you should calculate. So if it is within one standard deviation, then the answer will be 68%, and if it is within two standard deviation, it will be 95%, and if it is within three standard deviation, then it will be 99.7%. So calculate and answer this question, and I'll keep the key for this answer in the text comments. I'll pin and keep. So try to calculate. And one more thing is a small concept known as standard normal curve. So the standard normal curve is just a theoretical concept. So here the raw values are replaced by z-scores. So in the previous normal distribution curve, what we have seen, so the mean, median, mode will coincide, and left side and right side values will distribute. If it is weight in the previous example, so the mean weight will be in the middle and left side. It will be like in the x-axis, observations will be there. If it is weight 10 kgs, 20 kgs, 30 kgs, 40 kgs, like that it will extend. But those raw values here are replaced by z-scores. So the place where mean, median and mode is coinciding, so it will be denoted by 0 z-scores, and left side right side are denoted as -1 +1 z-scores. Remember, these are z-scores, not standard deviations. So they will be denoted as -1, -2, -3, +1, +2, +3, like that z-scores. So any raw data is given, we should convert it into z-scores and we should plot. And area under the curve in this also 1, and the standard deviation of this curve is 1. Just remember that it is a theoretical concept. Here raw values are replaced by z-scores. Thank you everyone, and like, share, subscribe for further updates.